Okay, so before the break, we talked about how to get the inverse function of a problem, right? Because last week, we only talked about radicals, right? Radicals and the straight lines, okay? And then there's one more part at the end here. We didn't do it yet, okay? It's asking other than domain range. It's also asking if the inverse function or is the inverse a function or not. Okay, we didn't say the inverse is function, right? We only had the original as a function f of x, but how come it's asking is the inverse or a function or not? So we need to understand what's the definition to be a function. I think we mentioned that in the very first class. Okay, let's go back to page 1. We said that if for every x, every value of x exists only one value of y. Okay, if that happens, then it's a function. Okay, each x can only have one y. So what that means on the graph, if you look at the red, right, the red one is the original. For each x, right, you can look at the x point. For example, when x equal to 1, okay, x equal to 1, then y has to be 3. Right? There's no other y values. Okay, each x can only be one y. For x equal to 0, then y has to be 4, right? For the red one. One x, only one y. But for the green one, right? For green one, if I have x equal to 3, I have a point that's up there, right? This green dot, 3 could be 1. If you look at the table, right? 3 could be 1. But then at the same time, when x equal to 3, 3 could also be -1. And that's all because of the plus minus sign. Remember, when you square root, you need to put plus minus sign. For each x that you put it in, it could either have a positive answer or negative answer come out. Okay, so when that happens, your graph is no longer a function. Okay, so to answer this part, you'll say no, inverse is not a function. Okay. So in your homework, you have question like this as well. Okay, asking you to check if the inverse is not is a function or not. So if you start with a problem, then your inverse will always not a function. Okay, because it become opening sideways. So we call that the vertical line test. Okay, you probably learned it in grade 10 about vertical line test for the function. Okay, we'll write it down at the bottom. Okay, so vertical line test for function. Okay, so does anyone remember how that works? Vertical line test for function. Chris, do you remember?
No, I don't.
Okay, anyone remembers? Daniel?
You just I guess I use a pencil and then go like from left to right, and then if x value like has more than one y value, then it doesn't work.
Okay. So from left to right, then that should be horizontal. Okay, so if you want to do vertical line, should be from top to bottom. Okay, so for example, let's say for the red one, right? Oh, I should use red. Red is the original one. Okay, and then if I draw a vertical line, right? No matter where you draw the vertical line, it only intersect once. Okay, the vertical line are the blue one. The red one is the original parabola, right? So this one will be yes, a function. Okay, yes means it's a function. Okay, now for the green one, the one that's opening to the left. If I draw a vertical line anywhere, right? Anywhere and cross more than once, right? Two intersection, then this one you'll say no. No means it's not a function. Okay, because that means each vertical line is like an x value, right? You draw a vertical line there. Okay, let me use this one, right? If I draw a vertical line, for example, this vertical line is at x equal to 1, 2, 3, 4, at -4, right? For x equal to -4, you get 2 points of the y, right? 2 different y values for the points. So it's not a function, okay? So this is your vertical line test. Okay, so now we all agree that the original is not a function. Therefore, we have a part B. Okay, so write the restrictions. No. So here it says, write the restrictions on the domain of the original function so that the inverse is a function. So what that means is, if you look at the domain of the original is this one, real numbers, right? Domain of original is real numbers. So it doesn't have restriction on it. You want to restrict that, meaning you make it smaller, okay? Instead of going to the left, going to the right forever, you want to restrict that, okay? Cut it. So that when you do the inverse, the new graph, okay, the new inverse graph will be a function. Okay, so if you look at the inverse, right? I'll draw that green part again, right? So this right now, it's not a function because it fails the vertical line test. How can I modify this graph so it becomes a function? So it can pass the vertical line test. What can I do with this, right? Which part should I erase so it becomes a function? Does anyone have any suggestions? For the green graph, how do I cut it or erase part of it so it will become a function? Yannick?
Could you like erase the bottom part?
Okay, so let's say let's do that, okay? So it cross that out, right? So your remaining graph will look like this way. So if you only have half of it, right? Then no matter where you draw the line, then it will pass the vertical line test, right? So you can erase the bottom half, or you could erase the other half, right? You can erase the top half, then that will also work. So when they give you a question like this, you can choose, okay? Everyone probably will choose different. Some of you choose to keep the top, some of you to choose to keep the bottom, okay? So it doesn't matter. So let's just pick one side, okay? So let's say if I want to keep the top part, okay? Just like Nick said, right? If I want to keep the top part, let's draw it on the graph here, right? For the inverse, if I want to keep this part so it's inverse, then where should we keep? On the original, I cannot keep both sides, right? If you have both sides, then your inverse will have both sides. So keeping the top, will be the same as keeping which side of the original? Because they should be inverse of each other, right? Remember, inverse graph, they have a symmetry line, right? Let me erase this part. Okay, they should have a symmetry. Mirror line, okay? So if the green one, we keep the top, where is the red part that we should keep? Anybody?
Is it the left side?
Left side, okay, let's try that, okay? So let's say if I draw the left side, and then we'll check with the mirror, right? Check with the mirror line. Does it look like cut in half? Is it symmetrical? Does it look like left, the symmetry line cut the whole graph in half? What do you think, Philip?
No.
Doesn't look symmetrical, right? Let's say if we try the other part, okay? Let's say we keep the right side. Right side will look like that. Does it look like symmetrical now?
Yeah.
Yeah, okay. So that's one way you can check, okay? Or you can just remember the positive side will be inverse of the positive side, right? The top means positive, right? Going up is positive. Going to the right is also positive. Just remember, like, for example, like we talk about open up, open down, right? Open left, open right. Down is negative. Left is also negative, right? There's a connection with the direction as well, inverse. So if you want to keep the top part, top half, then the original, you need to keep the right side. So keeping the positive side. Okay, top and right, they are both positive. Okay, so if I want to also, so the question wants us to write the restrictions on the original. So in our choice here, we are keeping the right hand side. Okay, so we'll say the restrictions will be x greater and equal to 0 because we're keeping the right side. Okay, it's talking about restriction on the original. If you are keeping the left side, okay, I'll just write it at the bottom. If the restrictions you chose is x less than or equal to 0, then your graph will be keeping the left, okay, and your inverse will be going this way. Okay, but since we chose the right side, then you're keeping the top and the right side. So your answer should be this one. Okay, do you have any questions? Can you raise your hand if you understand how we pick the side and get the restrictions? Okay, so you have your own choice, okay? You can choose, you either want to keep the right side or the left side. And then depending on which side you keep, you have different restriction, you have a different graph. Okay, Caleb, Daniel, Eric, Jocelyn, Nick, do you have questions about how to write the restrictions out? Because after this, we have one more example, okay, to do this whole thing again, right? Okay, Jocelyn, do you have questions?
No, I forgot to put my hand up.
Okay, okay. So let's look at question 11 now, right? We're gonna carry out the same thing again, but this time, of course, will be a little bit faster, right? Now, because before we had to review how to get APQ, okay? So let's take a look at question 11. And this time I'll let you guys to figure out the graphs of the original, okay, by yourself. So our f of x okay, I'm gonna use red, okay, I'll keep it as red. So think about what's the APQ for this one. This one is already in the form, okay? So what's the APQ form? So both question 10 and 11, they are already in the form, okay? Question 10 is missing the middle term, okay? Question 11, it already has the bracket, right? So you don't need to expand the bracket, it's already in APQ form, vertex form. So can you raise your hand if you found the vertex? Right, so Jenny, what's the APQ form look like?
Wait. Sorry, I'm not done. I thought you were asking for the just the
Vertex.
vertex.
Yeah, sure. What's the vertex?
Is it just 0, 0?
No, it's not 0, 0.
Oh, okay.
Okay. Nick, what do you think? Where's the vertex?
3, 0.
3, 0, close.
Oh,
Wait,
is it?
it's
Yeah, Jenny?
0. Never mind.
Jenny, you want to say something?
Is it 9, 0?
9, 0, no. Yeah,
Or
Nick?
0?
Nick, did you want to say something?
0, 3.
0, 3, no.
Jason,
Yes, Daniel?
is it -30?
Negative 3, 0. Yeah. Okay. Chris also said that. Okay. Okay. So now let's explain why. Okay. Why is it -3, 0? How did they get that? Remember, I already told you here, right? For this one, it's already in the APQ form. Okay. Let's review what APQ form look like. I'll write it on the top. Okay. A X. Okay, too small. Okay. So y equals to a x minus p squared plus q. Okay, the easiest one to get is the a. A has to be outside the brackets, right? Before the bracket. So there's a 1. That's how A. Okay, the next one easy to find is the q. Q is after the square. Right? Q is after the square. But then there's nothing behind the square. So that means your Q has to be 0. Okay, so I'll write it out. It'll be 1 and then bracket square plus 0. That's why the question doesn't need to show it's 0. And then the P has to be always after the minus, right? X minus something. But then in the bracket, it has X plus. So I need to rewrite it as x minus a -3. Okay, so then this will be your P is minus P, right? If you look at the form, plus Q. So that's where the -3 and 0 comes from. Okay, so now we got our table, I mean the vertex, right? Remember to put where to put the vertex in the table, right? So look at the example before. Where do you put the vertex in the table? And then once you get that, you can start the graph. Okay, I'll let you complete the table and the graph. And then you can raise your hand once you finish the parabola, okay, for the original. And then we'll do the inverse. Okay, let's check the table now. Okay, Susan, can you start from the top? What are your 5 points?
-5, 4,
Okay.
-4, 1,
Mm-hmm.
-3, 0,
Yep.
-2, 1,
Yep.
and -1, 4.
Okay, very good. Okay, so the middle point yours is your vertex, -3, 0, and you just graph left and right side, and then each x you plug it into the function, okay, to calculate the y. Okay, please raise your hand if you finish the graph, right? -3, 0. So this time it's open up, right? That's the line. Okay, once you finish the graph, you can start on the inverse. So for inverse, follow the 3 steps. Okay, look at the previous example. Step 1, write it as y. Step 2, switch x and y. Don't forget step 3, you need plus minus. Okay. Okay, Caleb, Eric, Evan, Justin, Philip, do you have question about graphing the original?
No?
Okay, please raise your hand if you finish the graph. Okay, all right, so work on the inverse now. So inverse, I'll be using the green. So step 1, step 2, step 3. Okay, so hopefully this time we don't get 5 different answers, huh? Okay, step 2, switch X and Y. I'll do that. Step 3, you need to isolate the Y. And please write your answer with a proper symbol, okay? F inverse of X equal. Please raise your hand if you have the inverse equation. Okay, Eric, do you have any trouble? Any questions?
When I like isolate the y, should I
Yeah.
square root the x first, or should I like expand the other side?
If you expand the right-hand side, it gets more y's, right? You get y squared plus 6y plus 9, okay? It will be difficult to isolate y. So you start with getting rid of the square first, okay?
Okay.
Yeah, you go from outside in. Okay, Evan, what's your inverse equation?
I don't know if it's right, but I got y equals square root x minus 3.
Square root x minus 3.
Minus 3.
Is the minus 3 inside or outside the square root?
Outside.
Outside, okay. So like that?
Yeah.
Okay. Eric, what do you think? Are you done?
Oh, I have the exact same.
Exactly the same? Okay.
Yeah.
Philip, how about you?
Same.
Okay, you gotta raise your hand so I know you're done, okay? Okay. Susan, how about you?
It's the same.
Same. Anyone got different?
Jason,
Yes, Daniel.
I got f of -1x equals plus or minus square root x, and then minus 3.
Okay, I hope you guys learn. We spent so much time before talking about plus minus. Okay, please don't forget in your homework, otherwise you will get them wrong, okay? If you put a square root on by yourself, right, in order to isolate, you need to have plus minus because the inverse will not be a function, okay? And the plus minus is the reason why it cannot be a function, okay? You get 2 options for the y. So remember, okay, so let's do the step by step, right? If I square root both sides, square root the left, square root on the right, right? The moment that you put it on, you need plus minus right away, okay? And the square root will cancel each other out. And then after that, you move the plus 3 to the left side, okay? So your inverse will now look like plus minus root x minus 3, okay? Otherwise, you don't get the full graph, right? You only have half of it. Okay, so let's go to the graph. Okay, can you guys complete the graph as well? So to get a graph, think about how we did the graph before. How do we get the table? Okay. So once you finish the graph, please raise your hand. And then before you complete it, right, think about, ask yourself, the original is opened up. So inverse should be opening which way? Okay, think about this question. All right, so let's check the table, all right? Angela, can you give us the table from top to bottom?
For x, it's just 4, 1, 0, 1, 4.
Okay, yeah,
And then y, -5, -4, -3, -2, -1.
yeah, very good. Okay, very straightforward, right? You just flip the original one. And then for the inverse, which way will it open? Okay, that's Evan. What do you think? Which way will the inverse open?
To the right.
Yeah, very good. Okay, so opens up correspond to open to the right. Okay, if it's open down, it will correspond to open to the left. Okay, down and left, they are like brothers. Okay, up and right, sisters. Okay, so 4, -5, 1, 2, 3, 4, -5. Where is that? 1, 2, 3, 4, 5. Okay. Yeah, 1, -4. Here, 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 and here. Right, so it goes this way. So this one's inverse, you can label your graph, and this one's original, okay? Now domain range, okay? Once again, please complete that table for the domain range and raise your hand. Okay, Sophie, what's the domain?
Is my mic working? Double
Yep,
check.
yep, it's working.
X is equal to all real numbers. Pretty
Yep.
sure.
Yeah, very good. Okay, what about range for original?
I got Y is bigger than or equal to 0.
Okay, thank you. And Lily, what do you think the domain range for the inverse then?
Domain is X is greater or equal to 0
Yeah, and then range?
is all real number.
Yeah, okay, very good. Okay, you just reverse the domain range of the original, okay, but still keep the X and Y at the same place. Okay, and then you can check with the graph, right? The inverse, it starts from 0, -3, and then moving to the right side. So that's why it's greater or equal to 0. Okay, make sure you double check. Now, one more question there, right? Is inverse a function? Okay, Philip, is inverse a function?
No.
Yeah, very good. Okay, so you can write it on the side. Inverse is not a function, okay? Because it fails the vertical line test. When you draw a vertical line, it will cross 2 places, okay? If you draw the vertical line for the red one, it will only cross once. So original is a function, inverse is not a function. Okay, last part. Just like before, please write the restrictions on the original. Okay, restriction on the domain of the original. So I would like you to do 2 kinds, okay, 2 options, because you can either keep the top half or the bottom half, right? Okay, so I would like you to do both as practice, okay? So draw both possibility and then write the restrictions on the original, okay, for both. Right, so once you've done that, you can raise your hand. So sketch both the restricted, okay? Sketch the restricted inverse and the corresponding function. Corresponding means the original. So sketch both after the restrictions. And now I'll ask you guys to sketch it on the screen, okay? Okay, please raise your hand if you finish both ways. So in the homework, you just need to do one way, okay? Just need to do one option. You either keep the top half or keep the bottom half. Okay, Chris, what did you choose to keep? What's the restriction you have for the first one?
X is greater than -3.
Greater than or equal to, right? Make sure you
Yeah.
also keep the equal, -3. Okay, then can you draw? Okay, I'll ask someone else to draw. Okay. Claire, then can you
Yep.
draw on in the first box on the left side? The one for greater and equal to -3. Okay, and the inverse, very good. Yeah, good. Okay, so it'll be this way. Okay, so make sure they are symmetrical, right? So this is at -3. Remember, your restriction is for the original, right? Not for the inverse. Okay, last second option. So this one, the first option is keeping the upper part, right? So that means second one should be keeping the lower part. All right, so Eric, what's the restriction for the second one?
Is it X is greater than -3?
We just did that.
Oh, wait, the second one. It's X is greater than equal to 0.
No. The first option is we keeping the right hand side, right? The right half or the upper half of the inverse. Okay, Eric,
Yeah, so it's Y greater than -3.
say that again. Can you
Oh.
say it one more time?
I'm not sure for this one.
Do you understand how we get the first one?
It's we took the right side of the function.
The original, right?
Yeah.
Okay, so that's why it's greater or equal to -3. So if we want to now keep, instead we keep the left hand side. What would you say the domain, the restriction? Eric? The left side of -3, how do you write it?
So less than equal to -3.
Yeah, okay. So use less than or equal to -3. So you have two options to write the restriction. Okay, and how do we draw the graph? Okay, Daniel, can you try to draw on the screen? Okay, yeah, that's good. Left side. Okay, and inverse. Yeah, okay, so remember to be careful of how you make the curve. Okay, make sure it shows that it's the lower half and the left half, right, of each. Okay, so when you show your answer for the homework, okay, make sure you get a few more points. Okay, so make a curve more clearly. Okay, you can use the symmetry line, right, to double check they should be symmetrical. So you just either pick option 1 or option 2. Okay, so now let's take a look at the homework. Okay, what kind of question you get? Let me erase the drawings. So I'll be assigning these ones. Okay, this is on page 15, I guess. Yeah. Okay, page 15 again, right? So over here, each of the following. First, you find the inverse. Okay, we've done that, right? For those two questions. And then you graph original and the inverse on the same grid. Okay, so please use a grid paper, right? So either you can print it out off the internet, okay? Use the grid. And then part C, you answer, is it a function? Okay, some of them is, some of them not. Okay, if it's parabola, when you inverse, it's not a function, but it's a straight line, then it will still be a function. Okay, so it also covers some of the older question. We did the inverse of straight lines, right? So if not, you need to give me restrictions on the domain of the original. Okay. At the end, use a table to show the domain range. Okay, table is talking about this table that we did. Right here, this table. Okay. So if it's a straight line, then you need to look at question 1. Not question 1, the one we did at first, right? If it's straight line, the inverse will still be a straight line. Okay. And then if it's a parabola, the inverse will not be a parabola, will have square root. Okay. If it's a square root, then the inverse will be half of the parabola. Okay, we have 3 kinds of inverse. So you'll do those questions, right? A, B, C, D for these 6 questions, 6 different graphs. So you can see 14 is a straight line. 19 is also a straight line. Other than those 2, the other ones are all parabolas. Okay, are we clear on what to do on the homework? Okay, you can raise your hand if you are okay with the homework. Okay, so if you have questions, you can stay after class. Okay, then I'll see you next week. All right.
Thank you, Jason.
You're welcome. Have a good weekend.
Thank you. Bye-bye.
Yeah.
Bye.